compute probabilities utilizing our counting tools, permutations and combinations. Okay. Now, when I indicated earlier that tree diagrams are okay back in section 10.4, but when you have a large number of possible outcomes, tree diagrams can become more difficult to draw, if not impossible. For that reason, we have to turn our situation over to our ability to count or enumerate using our permutations and combinations and the fundamental principle of counting. So that's what we're going to do in this section, is use those rules to actually compute more complicated probabilities here. All right, now here we go. Let's get started. Stacy has the option of selecting 3 books to read for a humanities course. The suggested book list consists of 10 biographies and 5 current event books. Total of 15 books. Stacy decides to pick the 3 books at random. Find the probability that all 3 books will be biographies. Okay. So, Les Almond, she is going to randomly select 3 textbooks from 15 total textbooks, and they want the probability that all 3 of the books will be biographies. Now, notice these selections are without replacement, and so these trials are not independent trials. Okay, so the probability of subsequent selections does change dependent upon earlier selections. All right, now all we're interested in is choosing 3 of the 15 books, and we want 3 of these books to be what? All biographies. Okay, so order really doesn't matter in how we select these 3 books here. Now, it comes down to this. We have 10 biographies at our disposal here, and we're going to select 3 random books from 15 books total, hoping that all 3 will be biographies. So, in the event that we do select all 3 books as being biographies, how many different ways can you select 3 biographies from 10 biography books available if order doesn't matter? Well, we're using our combination. That'll be 10 in combination with 3, which, you know, using your calculator would be 120. And hold on a second here. Let me show you on your calculator how you do 10 in combination with 3. I did post a real short video on that, but I put the link in our lecture video category on Canvas if you are still struggling with how to compute combinations or permutations. I'll show you on your TI-30 calculator how to do 10 in combination with 3 here, in case you forgot. All right, so this is our calculator here. We would type in 10 first, and then we would hit our probability button, PRB, and then go down and grab the NCR function. Notice the permutation function is above it. There's your combination function, and there's your factorial function. So 10, select this function, and type in 3. Answer, there's 120 different ways of choosing 3 biographies from 10 biographies that are available. Okay, 10 in combination with 3. There's 120 different ways. See that? They did the problem the long way using the definition of combination and utilizing factorials. You don't need to do that. You can just go to your calculator, pick up the NCR function, 10 in combination with 3, you get 120 different ways. So, ladies and gentlemen, Stacy will begin picking, will be picking 3 books total from 15 options. How many total ways can you pick 3 books from 15 books if order doesn't matter? This is the total number of outcomes of this experiment, 15 in combination with 3, which again, using your calculator, you can discover is 455. Therefore, the probability that Stacy, when she reaches in and randomly selects 3 books from these 15 books, the probability that all 3 selections will be biographies is going to be 120 ways of selecting 3 biographies from 10 biography books, divided by the total number of outcomes of this experiment. That is the total number of ways to select 3 books from 15 books, 455. Your probability is about 26% chance that Stacy, when she randomly selects 3 books from these 15 books, will select all biography books. Did that problem make sense there? That's the probability. All right, let's try another problem. What is the probability of getting 4 aces when drawing 5 cards from a standard deck of 52 cards? And again, we're assuming that we reach in and pull out a card, keep it out, pull out another card, keep it out, another card, keep it out, another card, keep it out. So this is an experiment without replacement again. Therefore, to compute this probability, we're going to have help from our combination function. Notice it doesn't matter in what order we choose these 4 aces. We just hope to get 4 aces and 5 cards drawn from the deck of cards. So a way to start this probability computation is to ask ourselves, how many ways can you select 4 aces from 52 cards where order does not matter? Well, where order does not matter, ladies and gentlemen, that's going to be 52 in combination with 4. Okay. So 52 in combination with 4 is going to be the total number of ways of selecting 4 aces from 52 cards. And if you get on your calculator and dial this up, 52, hit your probability button, PRB, select the NCR function, and then type in 4, and then enter. How many different ways can we select those 4 aces from this deck of cards if order does not matter? Well, there's quite a few ways. This is going to be equal to 270,725 different ways. Now, how many ways in general can we select? So this is what it's coming down to, ladies and gentlemen. We are trying to compute the probability of selecting what? 4 aces and 1 non-ace card. How many ways can we select 4 aces where order doesn't matter? That's going to be 52 in combination with 4. Now we're going to multiply this by how many ways can we select the non-ace card if order does not matter? Well, how many non-ace cards are there? There's 52 minus 4, 48 non-ace cards. Then we want to select one of them. Because remember, we're selecting 5 cards from this deck, 4 of which we hope to be aces and 1 to be a non-ace. Divided by how many total ways can you select 5 cards from a deck of cards 52 strong? That would be 52 in combination with 5 ways of selecting 5 cards from a deck. This is going to give you your probability. Now, when you do this problem, I strongly recommend that you enclose these probabilities inside, these combinations inside parentheses to stay off a logical error. And so, ladies and gentlemen, I want you to get on your calculator now using parentheses here. I want you to try to compute this probability. Go ahead and do that. Tell me what you get. All
I
right,
got 5.
5. Hold on a second here. Something's wrong. Can't have 5. Probability's gonna be bigger than 1. Something's wrong here. Let's see. So let's see here. So what did I have? I had 52 in combination with. Oh, wait a minute. Wait a minute. This is all wrong. Try this again. Probability of selecting 4 aces and 1 non-ace. Okay. So, ladies and gentlemen, how many aces do we have in a standard deck card? We have 4 aces available, correct? How many non-aces do we have? We have 48 what? Non-aces. So how many ways can I choose 4 aces among the 4 aces that I have available? Where order does not matter. That's going to be 4 in combination with 4. I do apologize. Times how many ways can you choose a non-ace from the remaining cards? You have 48 non-aces. We need to choose one of them. So that's going to be 48 in combination with 1. This then will be divided by the total number of ways you can choose 5 cards from 52 cards. 52 in combination with 5. This should work. Again, I strongly recommend that you put parentheses around the combinations. Otherwise, you could get a logical error. So let's try that now.
Now I got 0.000018,469.
2, 3, 4, 1, 8, 5. That's a very small probability. Turning this into a percent, shifting decimal point 2 places to the right. We'll turn it into a percent, 0.00185%. That's the probability when you select 5 cards randomly from a deck of cards that all 4 of them will be aces and 1 of them will be a non-ace. That's a very small probability, as you can see. Okay, so that should be your answer. All right, very small probability. You would leave your answer like this for Alex, though, okay? I just turned this into a percent so that we could fathom how small this really is. This is not even close to being 1%. This is like 185 thousandths of 1 measly percent chance, okay? All righty, let's go look at another example. And there's the answer down there. Notice, very small. All right, now, a combination lock. You remember when we were in high school, ladies and gentlemen, we had combination locks to open up our locker, where you had to go so many digits to the right, and then to the left, and then to the right, okay? Actually, a combination lock is really misnamed because I have a question for you. If to open up a combination lock requires 3 numbers, do you think it's important as to the order in which those 3 numbers appear in your combination?
Yes.
Because order matters here, they really should not call those combination locks. Technically, they should be called permutation locks because order matters. Anyways, let's read into this problem here. It says a combination lock, which I like to call it a permutation lock, has 40 numbers on it from 0 to 39. Find the probability that if the combination to unlock it consists of 3 numbers, it will contain the numbers 1, 2, and 3 in some order. Okay. Assume that numbers cannot be repeated in the combination. Okay. It is interesting to note that the combination lock should really be called a permutation lock since order of the numbers is important when you're unlocking the lock. How does the problem change if numbers can be repeated? Find the probability in each case here. Okay, so this is an interesting problem. They want to know what is the probability of the combination containing 1, 2, and 3. Okay. In some specific order, in some order. And so we have to try to, you know, figure this probability out here. Okay, so let's try to wade into it now. So we want to compute the probability that the combination consists of 1, 2, and 3 in some order. All right, so how many ways can we select 1, 2, and 3 in some specific order from the numbers 1, 2, and 3? Well, that's going to be 3 permuted 3 ways. Because again, we want these numbers 1, 2, and 3 to be in some order here. So this is the number of ways of selecting the numbers 1, 2, and 3 in some specific order, divided by how many total ways can I select a 3-digit or a 3-number rather combination from 40 numbers available, from the number is 0 to 39. Well, order matters, right, for any 3-number combination. So there's going to be 40 permuted 3 ways. So this is going to give us the probability of selecting a combination that consists of the numbers 1, 2, and 3 in some specific order. So let's get on our calculator. I would put parentheses around here. And how would we dial this up on our calculator? Well, we'll start with an open parenthesis, 3, get your probability button, go grab your NPR function, type in 3, closed parenthesis, divided by, open parenthesis, 40, go get NPR function, PRB button, NPR, type in 3, closed parenthesis, enter. And what do we get? What do we get for that probability?
0.00010115.
0.000101, something like that?
Yes.
Okay. So that's the probability. So this probability is approximately about 0.000101. And you can just leave it like that. You know, I mean, that's a very small chance, if you will, that our combination will consist of the numbers 1, 2, and 3 in some specific order of all the possible orders that could be constructed from 40 numbers, 3 at a time. All right. Now, notice that allowed for repeats in our numbers, so our combinations, repeats, 40 permuted 3 ways here. All right. So what if repeats are not possible? Well, if repeats are not possible, how is that going to change the probability of this here? Well, it's not going to change the numerator because we still want to get a combination. We're trying to still enumerate a number of different ways of getting the combination of 1, 2, 3 in some specific order. So the numerator still is going to be 3 permuted 3 ways. But now the denominator, ladies and gentlemen, is, let's see. Let's see. Let me see if order matter or order did not matter. Let's see. Okay, if numbers can be repeated. So in the first probability, a 40 permuted three ways, that does not allow for repeats in our digits. But if order can be, if digits can be repeated now, our denominator is going to go from being 40 permuted three ways to being 40 times 40 times 40. Because we have to form a three number combination, we have 40 digits that can populate the first, second, and third number spots. So this is going to be 3 permuted three ways, I believe is 6. This is going to be 6 divided by 40 cubed. And so dial it up on your calculator, and does the probability become larger or smaller? Well, as you would guess, the probability becomes even smaller now that if we could repeat numbers, as opposed to if we could not repeat numbers up here. So this is going to be 0.0000094 about. So this probability is smaller than this probability because now there's more a lot more different three number combinations you can form if you can have repeated digits. Because now you could have a combination that could be like 555 or 38, 38, 38. All right. So that stands to reason since the numerator did not change, but the denominator has gone from being smaller to larger, this fraction gets smaller. Okay. This fraction is smaller than this fraction.
That's about it.
All right, so there's your solution there. All right, let's try another one here. A store has 6 different fitness magazines and 3 different news magazines. If a customer buys 3 magazines at random, find the probability that he'll pick 2 fitness magazines and 1 news magazine. We're going to do this here. Now, do you think order matters in which they purchase these magazines? Do you think order is going to matter here? Probably not. So we're talking combinations. We have 6 different fitness magazines. F for FM, short for fitness magazines. And we have 3 different news magazines, NM. If a customer buys 3 magazines at random, find the probability that he'll pick 2 fitness. This is what we have. This is what we need. We need 2 fitness magazines and 1 news magazine. That's what we have, and that's what we need. So to compute this probability here, the probability that the person will buy 2 fitness magazines and 1 news magazine, okay, is going to be equal to how many ways can the person buy 2 fitness magazines from 6 that are available, where order does not matter. That's going to be 6 in combination with 2. And means multiplication and probability. We will discover that when we get into the addition and multiplication rules. And the person wants to select 1 news magazine. How many ways can we select 1 news magazine from 3 available if order does not matter? That's going to be 3 in combination with 1. Divided by how many total ways can I select 3 magazines from a total of 9 magazines? I got a total of 9. And I'm going to buy 3 of them. That would be 9 in combination with 3. Okay, get on your calculator and dial this up, ladies and gentlemen. That's going to be your answer. That's the probability that this person will buy 2 fitness magazines and 1 news magazine if they randomly buy 3 magazines from the 9 total magazines available. Go ahead, dial it up. Tell me what you get for the probability.
I got 0.0535.
0.5, what'd you get again?
0.535.
Yeah, okay. They got about 0.536, so whatever, 0.535, 0.536, that's good enough. So this is approximately about 0.535, about a 54% chance that when they randomly buy 3 of these magazines, that 2 of them will be fitness magazines and 1 of them will be a news magazine. There's your probability. So we're using our combinations and permutations to compute probabilities. All right, so that ends it for that. Let's go into our textbook now and see if we can dredge up some more fun.
Okay, I gotta go. We gotta go, babe.
All right, who's going? Who's going? All right. Anyways, let's get back to our problem here. Let's go to our textbook, section 10.5. Let's do some more problems. Section 10.5, these questions are going to be coming out of. As always, take a peek at the sections that we cover. It can only help reinforce what's going on during class. 10.5 is entitled Probability Using Permutations and Combinations. Okay, let's go down and see if we can compute some more of these problems here. Some of these are very interesting problems. All right, the first one I would like to look at here is number 11. We're going to do number 11 now. Actually, I will do number 11, and then I'll give you one similar to do for classwork. A student faculty government committee of 4 people is to be formed from 20 student volunteers and 5 faculty volunteers. Find the probability that the committee will consist of the following, assuming the selection is made at random. What's the probability that the committee will consist of all faculty members, 2 students and 2 faculty members, all students, 1 faculty member, and 3 students? All right, I'm going to dial up and show you how to do all these problems. So this is problem number 11 in section 10.5 in your textbook. All right, first of all, I would recommend that you document what we have available. And we have what? 20 student volunteers. SV is short for student volunteers. 5 faculty volunteers. FV is short for faculty volunteers. And the committee size, is to be 4. Okay. A, what's the probability that all of our 4 randomly selected people are faculty members? All are faculty members. Committee is going to be of size 4. So how many ways can I select 4 faculty members from 5 available? That would be 5 in combination with 4. Times, that means if I select 4 faculty members, that means that I basically have filled my committee. Technically, this is times How many ways can I choose 0 student volunteers from 20 student volunteers if order does not matter? That'll be 20 in combination with 0. This is going to be divided by the total number of ways in which I can choose 4 people from a total of 25 people. That's going to be 25 in combination with 4. So ladies and gentlemen, get on your calculator, let's dial this up, and let's see what that will give us. And when you get done computing that, we should get about 0.000395. Anybody get that? That'd be your answer. Anybody get that? All right. Did anybody by chance get that? All right, that's what I'm getting. Now in B, they want to know what is the probability that if I randomly select 4 people from these 25 people to put together my committee, what is the probability that 2 student volunteers are selected and 2 faculty volunteer members are selected? Well, how many ways can I choose two student volunteers from 5? If order doesn't matter, that's 5 in combination with 2. Times what's the number of ways I can choose 2 faculty volunteers from 20 available? Wait a minute, I got this backwards. The number of ways of choosing 2 student volunteers from 20 available would be 20 in combination with 2. This should be 20 in combination with 2. Times the number of ways of choosing 2 faculty volunteers from 5 available would be 5 in combination with 2. Divided by what's the total number of ways of choosing 4 people from 25 available. Order doesn't matter. This will be divided by 25 in combination with 4. Notice that these numbers always have to add up to the size of the committee. 2 plus 2 is 4. 4 plus 0 is 4. Okay. Get on your calculator and dial this up. 20 in combination with 2 times 5 in combination with 2. And divide that by 25 in combination with 4. All right, let me know if anybody gets that.
I got 0.10, 0.150.
0.150. That is what I got, 0.150. Okay, about a 15% chance that if you randomly select 4 of the 25 members, that your committee will consist of 2 student volunteers and 2 faculty volunteers. All right, for C, what's the probability that if I select 4 from 25 members, that my committee will consist of all student volunteers? Well, how many ways can I choose for, so to say all student volunteers is to say this is the probability that I choose 4 student volunteers and 0 faculty volunteers. Well, how many ways can I choose 4 student volunteers from 20 available? If order doesn't matter. That's going to be 20 in combination with 4. Times, how many ways can I choose 0 faculty volunteers from 5 available if order doesn't matter? That'll be 5 in combination with 0. Divided by how many ways can I choose 4 people from 25 total? Order doesn't matter. 25 in combination with 4. All right, get on your calculator and dial that up, ladies and gentlemen. You have your answer. The probability if I randomly select 4 of these 25 members, that my committee of size 4 will consist of all student volunteers.
Wait. 383.
Nice job. Yeah, that's what I got. 0.383, about a 38% chance that if I randomly select 4 of these 25 members, that my committee will consist of all student volunteers. That's correct. All right, we have one more here. D. What is the probability that if I randomly select 4 from these 25 members, that my committee will consist of 1 faculty member and 3 student members? So the probability of selecting 1 faculty volunteer and 3 student volunteers that will be on my committee. Okay. Well, how many ways can I choose 1 faculty volunteer from 5 available if order doesn't matter? That'll be 5 in combination with 1. And means multiply times how many ways can I select 3 student volunteers from 20 available? Order doesn't matter. 20 in combination with 3. This is divided by the total number of ways of selecting 4 committee members from 25 available. Order doesn't matter. 25 in combination with 4. So notice with all these problems, our denominators have remained the same. 25 in combination with 4. 25 in combination with 4. The denominator has never changed. All
I
right.
got 0.45.
All right, get on your calculator, dial it up. And 0.45 is approximately what I got. 0.45. So there's about a 45% chance that you will randomly select 1 faculty volunteer and 3 student volunteers to be on your committee, if order doesn't matter and how you select these. Is this making sense how we're using our combinations to compute probabilities like this here?
Yes.
Notice you always start with documenting on your paper what you have available, your committee size or the size of your sample that's required. Okay, and then what you need will be in your probability that you're being asked to compute. Okay, so notice there's a common theme here running throughout this. All right, let's go back to our textbook and see if maybe you could try one now. That was number 11. All right, so maybe you could try number 12 for classwork. We'll call this classwork number 1, number 12, A through D. Go ahead, ladies and gentlemen, see if you can do something with this now based on what you've seen with me do. Classwork 1.
I'm go. I'm not understanding this.
Let's just take a look at this problem here. Okay. Now, we have 7 executives to choose from totally. 4 are women, 3 are men. If we randomly select 3 of these executives, what's the probability that all of them selected will be women? That is to say, what's the probability that 3 women will be selected and 0 men will be selected? Well, how many ways can we select 3 women from 4 women if order doesn't matter? That is going to be 4 in combination with 3 times how many ways can I select 0 men from 3 men if order doesn't matter? That'll be 3 in combination with 0. This is going to be divided by how many ways can I choose 3 executives from 7 executives total? 7 in combination with 3. Dial that up. Your probability should be about 0.114. Did anybody get that answer?
Yes.
Okay. B, what's the probability that all 3 executives chosen are all men? Well, that's the same, the probability that I choose 3 men and 0 women. How many ways can I choose 3 men from 3 men that are available if order doesn't matter? 3 in combination with 3 ways. Times how many ways can I select 0 women from 4 women if order doesn't matter? 4 in combination with 0 ways. Divided by, again, 7 in combination with 3 ways of choosing 3 executives from 7 executives if order doesn't matter. Get on your calculator, dial this up. You have your answer to that problem. I got like 0.029. Did anybody get this? 0.029.
I did.
Okay. C, what's the probability that I randomly select 2 men and 1 woman to be on this 3-person committee? Well, how many ways can I select 2 men from 3 men available if order doesn't matter? That will be 3 in combination with 2 ways. Times, how many ways can I select 1 woman from 4 women available if order doesn't matter? 4 in combination with 1 ways. Divided by 7 in combination with 3 ways of choosing 3 executives from a total of 7 if order doesn't matter. Probability, 0.343. Did anybody generate that? Or C? Anybody get that one?
Yes.
All right. And then D, what's the probability that I select 1 man and 3 women? Wait a minute here. 1 man and 3 women? Did I read that one right? Or maybe I did not read that one correctly. That's not possible. I thought we were only choosing 3, weren't we? Oh, 1 man and 2 women. My bad. This should be 2 women. 1 man and 2 women. Well, how many ways can I select 1 man from 3 men available if order doesn't matter? That's going to be 3 in combination with 1. Times, how many ways can I choose 2 women from 4 women if order doesn't matter? That'll be 4 in combination with 2. Divided by 7 in combination with 3. And that probability is not correct. Hold on.
I got 0.514 for that one.
Point 514.
Yeah.
0.514. There we go. All right. Those are your answers. All right, that's for number 12 there. Okay. All right. Number 13. Let's see if you can dial this one up. A city council consists of 10 members. 4 are Republicans, 3 are Democrats, and 3 are independents. If a committee of 3 is to be selected, find the probability of selecting all Republicans, all Democrats, 1 of each party, 2 Democrats and 1 independent, 1 independent and 2 Republicans. See if you can crank all those probabilities out. Number 13. The only difference between this and the previous problems is that you now have 3 groups to choose from, not just 2. Republicans, Democrats, and independents. It works the same way, though. All right, number 13. Try that problem. We'll call that classwork number 2.
I don't get it at all. I got 4 for letter A. I'm not catching on to this at all.
All right. This is number 13. Section 10.5. Now, what do we have available? We have 4 Republicans, 3 Democrats, and 3 independents. If we select a committee of size 3, what's the probability that all 3 selected are Republicans? Well, that's saying the probability that we select 3 Republicans and 0 Democrats and 0 independents. We need 3 Republicans. We have 4 available to choose from. So how many ways can we choose 3 Republicans from 4 Republicans if order does not matter? That's going to be 4 in combination with 3. 4 in combination with 3 ways. Times, how many ways can we select 0 Democrats from 3 available? Order doesn't matter. That's going to be 3 in combination with 0 times how many ways can we select 0 independents from 3 available? Order doesn't matter. 3 in combination with 0 ways. Divided by how many ways can I select 3 politicians from 10 total available? 4 plus 3 is 10 total available. Order doesn't matter. That'll be 10 in combination with 3 ways. And when you get on your calculator and compute this all out, it should be about 0.033. Anybody get that there?
I did.
0.033. B, what's the probability of selecting all three of our politicians and they are Democrats? That's saying the probability that we select 3 Democrats and 0 Republicans and 0 independents. So how many ways can I choose 3 Democrats from 3 Democrats that are available if order doesn't matter? That's going to be 3 in combination with 3 ways. Times, how many ways can I select 0 Republicans from 4 that are available if order doesn't matter? 4 in combination with 0 ways. Times, how many ways can I select 0 independents from 3 available? Order doesn't matter. 3 in combination with 0 ways. Divided by 10 in combination with 3 ways to select 3 politicians from 10 available if order doesn't matter. 0.0083 when you get done cranking this out. Can anybody confirm that value, that probability?
Yes.
C, what's the probability of selecting 1 Republican and 1 Democrat and 1 independent? How many ways can I select 1 Republican from 4 Republicans available if order doesn't matter? That'll be 4 in combination with 1 way. And means times. How many ways can I select 1 Democrat from 3 Democrats available if order doesn't matter? 3 in combination with 1 way. And how many ways can I select 1 independent from 3 independents available if order doesn't matter? 3 in combination with 1 way. So this is the number of ways of selecting Republicans, Democrats, and independents. This is the number of ways of selecting 1 Republican and 1 Democrat and 1 independent from the number of politicians we have available from each party here. Divided by 10 in combination with 3. 0.30 is the probability. Anybody get that?
Yes.
D, what's the probability of selecting 2 Democrats and 1 independent and 0 Republicans? How many ways can I select 2 Democrats? 2 Democrats from 3 available if order doesn't matter. That'll be 3 in combination with 2 ways. And how many ways can I select 1 independent from 3 independents if order doesn't matter? 3 in combination with 1 way. And how many ways can I select 0 Republicans from 4 available? Order doesn't matter. 4 in combination with 0 ways. Divided by, you guessed it, 10 in combination with 3, 0.075 is the probability of selecting 2 Democrats and 1 independent and 0 Republicans. Did anybody get that?
Yep.
Last one. What's the probability of selecting 1 independent and 2 Republicans and 0 Democrats? How many ways from 3 independents can I choose one if order doesn't matter? 3 in combination with 1. Times from 4 Republicans available, how many ways can I choose 2 of them if order doesn't matter? 4 in combination with 2 ways. Times of the 3 Democrats available, how many ways can I choose none of them if order doesn't matter? 3 in combination with 0 ways. Divided by 10 in combination with 3. 0.15 is the last probability. Anybody get that last one?
Yep.
Oh. All right, so ladies and gentlemen, it looks like there's a common theme with all these problems here. We keep using the combination function, all right, to compute these probabilities here, and the denominator never changes. The denominator seems to always remain the same. Notice that. Okay, so that's one like number 13. And all of these are kind of like repeats. Do you agree? Just the same song and dance here for all these. Just different numbers. Okay, let me see something here. I don't want to mess these up here, mix these up. All right. Okay, let's see here. All right, number 15, we can call this another classwork. You know, number 15 works exactly like number 13. It's just a repeat, except the difference is we're not talking about politicians. We're talking about entrees. Food. A chef is choosing from 12 different entrees for an important banquet, 3 of which contain spinach. So how many do not have spinach? You got 12 different entrees, 3 of which contain spinach. So how many do not have spinach?
Nine.
9. 9 do not have spinach, 3 do. Does that make sense so far? Now it says the guests will have a choice of 4 entrees. If the chef chooses those 4 at random from the 12 that are available, find the probability that none of the 4 entrees chosen at random will contain spinach. So a hint, ladies and gentlemen, the probability that none of the 4 entrees chosen at random contain spinach is to say equivalently that we would have to compute the probability that 0 of the 4 entrees, I'm sorry, 0 of the 4 randomly selected entrees do not have spinach. Correct? Isn't that what it's saying? The probability that none of the entrees chosen have spinach is to say the probability that all 4 that are randomly chosen do not have spinach. Well, how many ways can you choose 4 entrees from how many that do not have spinach? How many do not have spinach?
9.
9. So how many ways can you choose 4 entrees that do not have spinach from 9 that are available if order doesn't matter? That'll be 9 in combination with what? 4, correct? Ways. Isn't that true? So this would be saying 9 in combination with 4 are all the ways of choosing all 4 entrees that do not contain spinach if we have 9 of those entrees to choose from that don't have spinach.
How did you get 9?
12 minus 3, 12 different entrees, 3 of which contain spinach. And so 9 what? Have what? No spinach, is that correct? Is that making sense? Is that correct or not? To say that. Well, entrees, 3 contain spinach, 9 must not contain spinach. Right? They want the probability that none contains spinach. Well, how many ways can you choose 4 entrees that do not contain spinach from 9 that are available? If order doesn't matter, I choose these. That'd be 9 in combination with 4. Technically, times, you don't really need to put this last one here. What are the number of different ways of choosing 0 entrees that contain spinach? That'd be 3 in combination with 0. Why is this last one not even necessary, 3 in combination with 0? Because what does 3 in combination with 0 compute to? Doesn't that compute to what? 1? For that reason, Lejon, you don't even have to put this at the end for this situation here, 3 in combination with 0. You can just say 9 in combination with 4 are the number of ways of choosing 4 entrees that do not have spinach from 9 that are available. Now, this has to be divided by how many different ways can we choose 4 entrees from a total of how many? 12 total? That'd be 12 in combination with 4 ways. All right, that's going to be your answer for problem A here when you get on your calculator. So go ahead and see if you can bring that up on your machine. Make sure these should be in parentheses here. What do you get? Anybody?
Zero 0.255.
Same.
0.255. 0.255. Good. All right. Now, for classwork number, I forgot how many already. Just call it classwork. I want you to complete 15 C and D. D is trivial, ladies and gentlemen. No calculation needed for D. I hope you can realize that. You complete 15 C and D for a classwork. I will do B. Okay, don't worry about that one. I'll do this one. You do 15 C and D. Go ahead and finish those.
I got him.
All right. We have 12 total entrees to choose from, 3 of which contain spinach, 9 of which do not contain spinach. In C, if we randomly choose 4 entrees from the 12, what is the probability that 3 of those 4 will have spinach and 1 does not have spinach? Well, how many ways can I choose, okay, 3 entrees that have spinach from 3 entrees available that have spinach? If order doesn't matter, that'll be 3 in combination with 3 ways. Do you agree? And how many ways can I choose 1 remaining entree of the 4 that does not have spinach if I have 9 of them to choose from, if order doesn't matter? How many ways can I choose 1 from 9 if order doesn't matter? 9 in combination with 1 way. Divided by, okay, what's the total number of ways in which I can choose 4 entrees from 12 entrees totally, if order doesn't matter? 12 in combination with 4 ways. When you get on your calculator, dial this up, ladies and gentlemen. You should have the probability of this occurring. What is the probability of choosing 3 that have spinach and 1 that does not have spinach? Did we get 0.0182? Anybody? Did anybody get that?
Yes.
All right. Now, what is the probability that all 4 of my randomly 4 chosen entrees from 12 have spinach? Ladies and gentlemen, there is no calculation necessary for this problem, because if you look at this, think about it. We only have 3 of the 12 that have spinach. How is it even possible then to choose all 4 that have spinach if only 3 are available that have spinach? The answer is what? 0. Did anybody get that?
I got that.
That's your answer. That's impossible. Because we only have 3 of the 12 that contain spinach. You cannot choose 4 that all have spinach then. It's impossible. Okay. All right, I promised I was going to do part B for you. This one, B, is a little bit more challenging. It says, what is the probability of choosing at least 1 with spinach? At least 1 with spinach. Well, I'm going to say at least 1 with spinach really means what? At least 1. At least 1 is really saying that I could choose what? 1 with spinach, or 2 with what? Spinach, or 3 with what? Spinach. Why can I not say or 4 with spinach? Why can I not say or with 4 with spinach? Or 4 with spinach?
There's only 3
There's only
dishes.
3. Yeah, there's only 3 that contain spinach. We got to stop here. So this is what it's saying here. To do part B of this question, the probability that of the 4 randomly selected entrees from 12 available, that at least 1 of them will contain spinach, is to say equivalently that is the probability of 1 will have spinach, or 2 will have spinach, or 3 will have spinach. Okay, so this is really saying, all right, the probability that 1 will have spinach, or means addition, or the probability that 2 have what? Spinach, or plus, or the probability of 3 have spinach. Let's work on this probability first here. What's the probability that one has spinach of the four selected? Well, how many ways can I choose one with spinach from three that are available that have spinach? That'll be three in combination with one way, correct? Times, ladies and gentlemen, if I can choose only one that has spinach, then that means the other three of the four randomly chosen entrees from 12 must not have spinach. So how many ways can I choose four entrees with no spinach if I have 9 available? If order doesn't matter, that'll be 9 in combination with what? 3. Notice, one entree is to be chosen with spinach, 3 are to be chosen without spinach. And this is all divided by, you guessed it, 12 in combination with what? 4. Plus, now, what's the probability of choosing exactly 2 that have spinach? Well, how many ways can I choose 2 entrees that have spinach from 3 available if order doesn't matter? That'll be 3 in combination with 2 ways. Times, well, to choose 2 that have spinach is also to say I would also have to choose 2 that don't have spinach. So how many ways can I choose 2 that don't have spinach from 9 that are available if order doesn't matter? That'll be 9 in combination with 2 ways. All over 12 in combination with 4. Plus, what's the probability of choosing 3 that have spinach? Well, how many ways can I choose 3 entrees that have spinach from 3 that are available if order doesn't matter? That'll be 3 in combination with 3 ways. And this is saying that I choose 1 that does not have spinach. Well, how many ways can I choose 1 that does not have spinach from 9 that are available? If order doesn't matter, that'll be 9 in combination with 1, divided by 12 combination with 4. There you go. So unfortunately, you're going to have to use your, your combination function quite a bit here, correct? So and all this is going to be divided by what? You know? All right, so I'll tell you what, and you might want to put parentheses around this whole thing here. Very important to put parentheses around the whole darn thing. All right, ladies and gentlemen, and parentheses down here. Go ahead, get on your calculator and see if you can dial that one up. This one requires a little bit more work because we're adding together 3 different probabilities. Just let me know if anybody can bring that up on your calculator. Just make sure you use all those parentheses. That's very important.
Oh,
Hey, you know what, ladies and gentlemen? There was an easier way we could have done this problem by using our complementary probability rule. It would have saved our butts big time. I have a question for you. What's the complementary event to saying at least 1 with spinach? At least 1. So in other words, this is saying the probability that X is what? Greater than or equal to 1. Do you agree? What's the complementary interval for saying X is greater than or equal to 1? Isn't this the complementary probability rule that could be used in saying 1 minus the probability that X is what? Less than 1? But to say X is less than 1, ladies and gentlemen, isn't that to say the same thing that if X is less than 1, that X would be equal to what? 0? In other words, to compute this laborious probability, we could have said this is really equal to 1 minus the probability that what? None of our entrees have what? None have spinach. Wait a minute, didn't we compute that one of our problems? The probability that none have spinach? Didn't we do that one? I could have swore we computed that one. Didn't we? Wasn't that one of ours that we computed for this problem? Probability of none have spinach? Or was it? Maybe I'm hallucinating. No, it was A. What was the probability that none had spinach? What did we get for A? What was the probability that none had spinach? Wasn't it 0.255? All we had to do for this problem is take 1 minus the probability that none have spinach, which we already computed in part A. What's 1 minus 0.255? You got your answer for this one. What does that give you? 0.745?
Yes.
See how much easier that is, ladies and gentlemen, with the complementary probability rule? This would work, but it's a lot of work. You don't have to go through all this work. It's easier just to use the complementary probability rule here. Stays off all that work. All right. 0.745 is your answer. And I guarantee you, if you go through all this business, you'll also get 0.745. You should. It has to be equivalent to this. All right, just a couple more here. In our textbook, number 16. I'll work this one out. There are 50 tickets sold for a raffle for a student art auction, and there are 2 prizes to be awarded. If Deontay buys 2 tickets, find the probability that he'll win both prizes. So I have a question for you, ladies and gentlemen. How many winning tickets are there of the 50 tickets that are out there?
2.
There's 2. Do you agree? What's the probability that this person, Deontay, if he buys 2 tickets, will win both prizes? Well, I'll work that out. The probability of winning both prizes. Now, how many winning tickets are out there totally? There's 2. Do you agree? Of the 50, there's 2 winning tickets. So, ladies and gentlemen, how many ways can you select 2 winning tickets from the 2 winning tickets that are out there available? There's 2 winning tickets. And there's 48 what? Losers. Do you agree? Make sense? So to say that this person wins both prizes is to say that the person wins what? 2 prizes. Well, how many ways can you choose 2 prizes from 2 winning prizes from the 2 that are out there available to choose from? If order doesn't matter, that would be 2 in combination with 2 ways. Divided by how many ways could you select 2 tickets from the 48, from all the tickets that are out there? How many tickets are out there totally? 50 total tickets out there. How many ways can you select or buy 2 tickets from 50 if order doesn't matter? 50 in combination with 2. I already worked this probability out. Your answer to that question, ladies and gentlemen, is going to be about 0.00082. That's your probability of winning both prizes. That's not even 1% chance. So it's very slim that you'll win both prizes. That one's done. That's number 16. By the way, 2 in combination with 2 works out to be 1. This is 1. Your numerator is equal to 1. Okay. All right, let's try another one here. That one's done. Let's see, number 19. Find the probability of getting any triple digit number where all the digits are the same in a lottery game that consists of selecting a 3-digit number. Find the probability of getting any triple digit number where all the digits are the same in a lottery game that consists of selecting a 3-digit number. So, ladies and gentlemen, what is this even saying here? What's the probability of getting a triple digit number? Triple digit number in a lottery game where we select a 3-digit number. Well, how many ways can we get a triple digit number out there? We could get a what? A 000, or we could get a 111, or we could get a 222, or a 333, or a 444, or all the way up to 999. Do you agree? Divided by how many ways, ladies and gentlemen, could I get a 3-digit number from the fact that I have 10 digits to select from for each of the digits? For instance, consider this to be like 3 little mailboxes here. How many ways can you populate the first digit? There's 10 digits to choose from: a 0, a 1, 2, 3, 4, 5, 6, 7, 8, or 9. There's 10 ways to populate the second digit choice, and there's 10 ways to select the third digit for a 3-digit lottery ticket. According to the fundamental principle of counting, there's 10 times 10 times 10 ways of putting together a 3-digit lottery ticket. And of those, how many would be triple-digit lottery ticket numbers? Well, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways in which you could choose a triple-digit lottery ticket. Of the 1,000 total number of ways you could choose a 3-digit. So there's 10 different ways. There's 10 different ways to choose a triple-digit lottery ticket from 1,000 different lottery tickets that have 3 digits in them. So the probability of choosing a triple-digit lottery ticket of the 1,000 that are available out there would be 10 over 1,000, or 1 over 100, or that'd be 0.01. That's your probability. Okay? That's your answer. That's one like number 19 there. Okay. Just trying to show you some more of these that do exist in here. Number 23, the combination lock, in example 3 that has 40 numbers on it from 0 to 39. And the combination consists of 3 numbers in a specific order with no repeats. 3 numbers in a specific order with no repeats. Find the probability that the combination consists only of even numbers. Well, how are we going to do this problem here? Let's see. Find the probability that the combination consists only of even numbers. Okay. And there are 40 numbers to choose from on this combination log, 0 to 39. And we're going to choose 3 numbers from the 40 that exist. What's the probability that the combination consists of only even numbers? Only even numbers. Well, I have a question for you. How many even numbers exist out there for this combination lock? We got 0, 1, 2, 3, 4, 5, all the way up to what, 39 to choose from. How many of these numbers are even? Well, that's gonna be 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. That's 20. 20 even numbers that are 20 numbers of the 40 that are even. So what's the probability of choosing an even number combination? If order matters, of course, because it does for a combination lock. Well, how many ways can I choose 3 of these even numbers from the 20 that are available if order matters? That'll be 20 permuted 3 ways. Divided by how many ways can I choose 3 numbers from 40 numbers that are available for the entire combination lock? That'll be 4 if order matters. That'll be 40 permuted what? 3 ways. Ladies and gentlemen, this will give you your probability for this problem number 23. And I already worked it out. This gives you approximately about 0.115. That's your answer to problem 23. 0.115. All right, let me see if there's anything else in here. Problem 26. You'll get second prize in a lottery game if you match 4 of 5 numbers. Find the probability of winning second prize if you buy 5 tickets. Let's see what's going on here. Why does it go back to 25 here? Oh, here it is. In one lottery game, contestants pick 5 numbers from 1 to 40 and have to match all 5 for the big prize in any order. So 1 to 40 are the numbers we have available to choose from. And for number 26, what's the probability of matching winning second prize? In order to do that, we got to match 4 of the 5 numbers that are selected. Find the probability of winning second prize if you buy 5 tickets. Okay. So, what's the probability of matching 4 numbers of the 5 that are, selected? Well, let's see here. So there's 5 what? Let's see. There's 5 numbers of the 40 numbers out there that are what? Winning numbers, correct? 5 of them. So we have 5 winning numbers to choose from that are winning numbers. So what's the probability of matching 4 of the 5 winning numbers, or of getting 4 of the 5 winning numbers? Well, how many ways can you get 4 of the 5 winning numbers that are out there if order doesn't matter? That'll be 5 in combination with 4. All right. Now, 35 of the 40 numbers are not winning numbers. 5 of them are, 35 are not. So what's the probability of matching 4 of the 5 winning numbers? Well, how many ways can I choose 4 of the 5 winning numbers if order doesn't matter? There's 5 winning numbers out there. How many ways can I choose 4 of them if order doesn't matter? It'd be 5 in combination with 4. And my 5th number that I choose has to be a losing number. How many losing numbers are available out there? There's 35 losing numbers available out there. And how many ways can I choose 1 of the 35 losing numbers if order doesn't matter? That'd be 35 in combination with 1. Divided by, ladies and gentlemen, how many ways can I choose 5 numbers from 40 numbers that are out there available? I have 40 numbers total available. How many ways can I choose 5 of them if order doesn't matter? That number of ways. Compute this probability, and if you buy 1 ticket, your probability of winning is small. is like 175 over 658,008. Can anybody dial it up as a decimal for me right now? Tell me what that is in the decimal. Let's see, 175 divided by 658. That's small. 0.000266. And if you buy 5 tickets, what's your probability of winning? Does that enhance your ability to win or not? Well, probability of winning with 5 tickets is going to be nothing more than 5 times this probability. 266. And that only brings your chance up to winning to 0.0013. Okay, so that doesn't really help your chances much better if you buy 5 tickets. All right. Okay. So I think I've shown you one of each type out of here, ladies and gentlemen. I'll let you go. If there's any questions or comments, I'll stay on the line for a couple minutes to address those. All right. If not, have a great weekend. Take care, and just remember the due dates for what's available and open on Alex. All right.